So PLM, you can write it like this. These are not simple things. You should work hard to understand all this. Then YLM of theta phi, we can write it as CLM PLM of u e to the power of im phi, where CLM is the normalization constant. How to find, that is, normalize this YLM theta phi, so you can get the normalization constant CLM. That also not easy. Minus 1 to the power of m 2l plus 1 divided by 4 pi l minus m factorial divided by l plus m factorial to the power of half. Okay. Now you can put back u equal to cos theta. Then YLM theta phi becomes equal to minus 1 to the power of L plus M 1 by 2 to the power of L factorial 2L plus 1 divided by 4 pi L minus M factorial divided by L plus M factorial to the power of half sine to the power of M theta into d by d cos theta L plus M sine theta to the power of 2L e to the power of im phi. Very complicated equation. So this is the expression for final expression for YLM theta phi. So YLM theta phi is known as spherical harmonic of order L. So this is the common eigenstate of common eigenfunction of L square and LZ. So this is not easy to derive, but these are some standard procedures. Very lengthy equation for YLM theta phi. So this is the common eigenfunction for L square and LZ. Now we have to discuss some of the properties of spherical harmonics YLM theta phi. First one is here also I cannot prove all this. I can only simply state what are the properties. Properties of spherical harmonics. First one, YLM theta phi. You take the complex conjugate of YLM theta phi. Okay, star YLM theta phi star YLM star theta phi. This is nothing but minus 1 to the power of M Y L minus M. This becomes minus M theta phi. Or you can write in different way, minus 1 to the power of M YLM minus theta minus phi. That is one property of spherical harmonics. You take the complex conjugate, Instead of, you can do like this. Second property, orthonormality. So in spherical harmonics, these are the wave functions. So they are also orthonormal. Spherical harmonics are a complete orthonormal set of functions. So integral YLM star theta phi YLM theta phi integrated over solid angle d omega is delta LL dash delta MM dash. Okay. So this is another property of, this is known as orthogonality. Orthogonality of spherical harmonics. Now one more property is the parity. Parity operation of spherical harmonics. You replace x by minus x or y by minus y and z by minus z, or simply replace r by minus r. So what is the parity of YLM theta phi? So parity operator acting on YLM theta phi is YLM phi minus theta phi plus phi. Or in another way, you can write it as minus 1 to the power of L YLM theta phi. You can prove that. So parity is this one, minus 1 to the power of L. So parity is minus 1 to the power of L. So when parity is even, when L is even, or parity is odd when L is odd. When L is even, parity is even. When L is odd, parity is odd. Okay. So these are the some of the properties of spherical harmonics. These are the solutions, common eigenstates and solutions of L square and LZ. Okay. So today I am winding up the class. I will continue in the next class. Okay. Thank you.